Hello everyone, my name is Morhindal.
And I'm Laminar.
And I'm Jake Rising.
So our project is on laminar flow. So laminar flow is a constant, steady flow of a fluid. So the laminar flow should look almost like it's not moving.
For our project, our materials used were we got two 5-gallon buckets, 4-foot plastic tubing, a syringe, food coloring, and a water pump. And one bucket is full of water.
Alright, so we have our water bucket here, full of water, has a pump inside. And then across is the tube with the syringe on top with the food coloring inside. Then across we have an empty bucket that the water is going to go into.
To start our procedure, we will start the water pump and start flowing water from this bucket into this one. After both ends of the tubing are submerged, you can unplug the water pump. And since both ends of the tube are submerged, the water will continue to flow from the bucket with more water to the bucket with less water. And as it continues to fill up, the current will slow down as the buckets become more even. And once they're even enough, the water will be slow enough and consistent enough that we'll be able to show you laminar flow with our food coloring. Right now it's turbulent, as you can see, it mixes immediately. After both buckets are pretty evenly full, and the water's still flowing very slowly, you can start to put the food coloring in, and it should stay pretty straight for a while until it breaks up and mixes. That way you can see it pretty good. We should have put the tape right there in the middle, but you can tell it's still pretty straight.
Look at that.
It's pretty straight.
That is what you
That's
call
straight.
laminar flow.
It's perfect.
It's focused.
It's beautiful.
It's my blood.
It's right there we're looking for.
Yeah, there you go. Get it right here. Look at it. Whole thing.
Nice.
It's done moving. I don't think it's going. No, it's still going. It goes right to the
As you
bottom.
guys can see, when the velocity slows down, we can see a smooth laminar flow.
So the Reynolds number is what determines laminar flow. If Reynolds number is under 2300, the flow is considered laminar. If the laminar flow is between 2300 and 4000, it is considered transitional flow. If Reynolds number is greater than 4000, it's considered turbulent. So we're looking for laminar flow, so we're looking for Reynolds number to be under 2300. Our knowns for this is the viscosity of water. So the water we have is just room temperature, which is right around 70 degrees Fahrenheit. And by searching them online, the viscosity of water is just 0.37344 millimeters squared per second. And then the diameter of the tube that we use is 1/2 inch. So the only unknown for the equation that we have is the velocity. So we know the diameter, we know the viscosity, and we know Reynolds number has to be under 2300, or at least, or 2300 or under. So the calculations here to find velocity, the equation is right here. It's Reynolds number, which we want to be 2300 or under, so we're going to use 2300 here to find the maximum velocity. And we know the viscosity, but we changed the viscosity, the unit, to millimeters squared per second into meters cubed per second. So 0.37344 millimeters cubed or squared per second is equal to 3.7344 times 10 to the negative 7 meters cubed per second. So then after plugging these into our equation, we have 2300, which is Reynolds number, and then we have our viscosity, 3.744 times 10 to the negative 7 meters cubed per second. And then we have 0.0127 meters, which is just a diameter, but instead of inches, that's what 0.5 inches is in meters. And then This is the work done out on top, 8.58912 times 10 to the negative 4 over 0.0127. And then after solving, we get a Vmax of 0.0676 meters per second. Therefore, the laminar flow, in order for it to be laminar, the water in the tube must be traveling no faster than 0.0676 meters per second. When V is less than 0.067 meters per second, but not 0 meters per second, the flow is considered laminar. This is another example of laminar flow with a balloon and some duct tape. You can go ahead and pop it.
Go.
Come on, man.
Steady flow. Another example of food coloring.
It's orange.
As you saw in the balloon video, the flow of the balloon is laminar because the diameter of the hole in the balloon is constant, and the balloon keeps a constant pressure, keeping a constant velocity of the outflow of water, which creates a laminar flow.
So as you can see from the video, we proved that the flow through the pipe, through the tubing, was laminar because the food coloring didn't mix straight away with the water in the pipe, and that's because the current is consistent, and once you mix the food coloring, it stayed in a steady stream and didn't break up immediately.
So some advice on what not to do with this experiment is when you do the syringe part, putting too much food coloring in the pipe will make it spread everywhere and it will not look laminar at all.
Don't put in so much, don't put in so much. Oh my god. You're putting too much, man.
Secondly is putting the food coloring in too early into the tubing, because then it will just be turbulent and flow all at once.
As you can see, it mixes immediately.
A third thing is just make sure there's no air bubbles in the tube when you put the food coloring in.
And thank you everybody for watching. Make sure you like, subscribe, and comment, and peace out.